Hi everyone. In this video, we will see how VXLAN works with BGP EVPN. And what we will be doing is, in this example, we will just configure VXLAN bridging, which means that server 1 and server 2, they belong to the same subnet, which further means that we that the packets, they will remain in one VNI, VXLAN network identifier, which means that we don't have to route the traffic between the VNIs. I'll make a separate video for VXLAN routing as well with BGP EVPN. So now let's see how are we going to configure VXLAN bridging with BGP EVPN. So here again, this is our simple topology, okay, and we are again using Arista switches. Uh, it's an example of VXLAN bridging with BGP EVPN. When we say VXLAN bridging, it means that server 1 and server 2, they belong to the same subnet. So it's intra-subnet communication, okay, which means that the VNI remains the same. So on the C leaf 1 and the B leaf 1, we need to use one VNI to keep it in one segment. Okay, in the previous videos, there was no control plane. It was VXLAN flooding. Okay, but here we will use BGP EVPN in the control plane. So let's see how we do it. Please note that in my all the videos, you can find the configurations in the video description. Okay, I received some emails and people were asking me for the configurations, so they are already there. So now, before we move forward, let's visualize what is VXLAN bridging. Okay, so first let's see what is VLAN switching. Simple. So suppose it's a switch. Okay, host 1 and host 2 are uh, connected to the switch with VLAN 10. Okay, so for host 1 to be able to reach to host 2, we have to put both the hosts in the same VLAN. It's simple VLAN switching. Now just look on your right side. In the case of VXLAN bridging, just think of your data center fabric as one big switch. Suppose host 1 is connected to leaf switch A, and host 2 is connected to leaf switch B. Now, in the case of VXLAN, this number, the VLAN is no more significant. It is just locally significant. The number which is now important is the VNI. In this case, L2 VNI. We have to make sure that we for one subnet we map the VLAN to the right VNI. Now, what is VXLAN? If you have not watched my previous videos, I strongly recommend please go and watch. I mean, for anyone who is starting to learn VXLAN, those videos are a must. Okay, and it will give you a really good idea about the VXLAN. Here, I will just explain briefly what is VXLAN. VXLAN facilitates the extension of layer 2 networks over layer 3 infrastructure. What does that mean? Please note these words: layer 3, layer 2, and extension. So, and these are the layer 2 networks. So we extend these layer 2 networks over this underlay, layer 3. And how do we extend? We extend with the help of VXLAN, L2 VNIs and layer L3 three VNIs. When we say L2 VNI, it's bridging. When we say L3 VNI, it means we want routing. So now, what is BGP EVPN? MP EVPN is a standards based protocol, based control plane protocol for VXLAN to advertise MAC addresses, MAC and IP bindings, and IP prefixes. So this is a unique protocol which can advertise MAC addresses as well. Okay, IPv4, IPv6, and MAC addresses. Now the question is, what can we do with BGP EVPN that we cannot do with VXLAN flooding? So in the previous videos, you have seen that. I mean, we were able to ping from server 1 to server 2 with VXLAN flooding. So what's the fun? Why do we have to use BGP EVPN? Okay, there are many benefits. Okay, and two main benefits are VTEPs can be automatically discovered and VXLAN tunnels can be automatically established, simplifying network deployment and expansion. And then EVPN can advertise both layer 2 MAC address information and layer 3 routing information. These two things you cannot get in the VXLAN flooding because there was no control plane. I want to explain it a bit further. When we say that VTEPs can be automatically discovered, what does that mean? So look here. Suppose now this is your data center. You have more than two leaf switches. You have suppose many leaf switches, okay? And you have host 1, host 3, and host 6 in the VNI 10,000. I mean, in the same subnet. You see, they are in the same subnet. And then you have some host in maybe L2 VNI and VNN 20 and different. But host 1 and host 3 and host 6 are on different leaf switches and they never talk to each other. So it's the first time host 1 wants to talk to, suppose, host 6 in the same VLAN. So when it sends the ARP request, okay, it will send a broadcast ARP request to leaf 1. When leaf 1 receives this request, how would leaf 1 know where to send the packet? It cannot send to all the leaf switches like leaf 2, leaf 3, leaf 4, leaf 5, leaf 6. So we need to tell this leaf switch that where does the host in this subnet reside or in this L2 VNI reside. So in the case of VXLAN flooding, we mentioned that explicitly here. You see, in flood and learn mode, we have to manually configure the remote VTEPs. So here we will, in the leaf switch 1, we will configure it manually and we will tell the switch that in the VLAN 10, you will send the bump traffic to this VTEP, VTEP this, and VTEP this. So you will repeat this command 2 times on this switch, and when you come here, you will mention about this switch and this switch. And similarly, when you come on, when you come to switch 6, you have to put explicitly that for VLAN 10, you need to send the broadcast traffic to switch leaf 3 and leaf 1. So this is not an efficient process. So with BGP EVPN, you don't have to do this. What happens is as soon as you configure the control plane, okay, with the VNI, the switch automatically starts to advertise. It starts to show its interest that okay, I am here to receive the traffic for this VNI. So this is the main difference. Okay, and uh, as I mentioned earlier, VTAP discovery and end host information learning are both data plane driven processes that generate a significant amount of flooding traffic. Okay, so in flood and learn method, both the VTAP discovery and end host communication are both data plane driven processes, which means it I mean there is significant amount of flooding traffic, and BGP EVPN resolves both of these issues. I hope it makes sense. Now the question is how BGP EVPN makes it possible. So with the help of route types. Okay, so with BGP EVPN there are mainly 5 route types. Route type 1 and 4, they are for use in multi-homing deployments. So most of the time you will be concerned with route type 2, route type 3, and route type 5. So route type 2 is it is used to advertise the NLRI, network layer reachability information for MAC and MAC IP, which is the ARP. Okay, so as soon as the switch learns MAC or the ARP, it will advertise that information via route type 2. So now next type 3, it use this route route type to signal desire to receive bump traffic for a VNI, broadcast, unknown unicast, and multicast traffic. And then the route type 5 for layer 3 VPN like IP prefix and VRF uh, information. So when the switch has to advertise that kind of information, it will use route type 5. Now, before we jump onto the CLI, let's divide our VXLAN bridging with BGP EVPN into steps. So in step 1, what we will do is we will configure OSPF, okay, between leaf switches and spine. You can use IGP, you can use BGP, it's up to you. In Cisco implementations, you will mostly see that there is OSPF implemented in the underlay, but Arista recommends eBGP because it's more scalable. I will make video on that as well, but I just wanted to keep things simple, so I will use OSPF. But the primary purpose is to establish IP reachability between these loopback addresses. We just want to reach these addresses, so this is the reason we are building an underlay. So now in step 2, what we will do is now step 2 has 2 parts. One is the control plane and one is the data plane. So in the control plane, what we will do is we will configure BGP EVPN peerings between the loopback addresses, between spine and leaf 1 and C leaf 1 and spine and B leaf 1, and spine will act as a route reflector. So in step 2b, in step 2b, what we will do is we will set the VXLAN interface on these leaf switches as loopback 0, because we want to enable the VTF functionality, and for that you need to define a source interface on the VXLAN interface. So once at this point our underlay is ready, our overlay is ready. Now we are ready to build layer 2 or layer 3 VPN services. So this demo is related to VXLAN bridging. So he will be focusing on layer 2 VPN. So now let's move on to our next step, step 3. So in this step, what we will do is we will configure our layer 2 VPN. Again, this step has two parts. One is the control plane and the next is the data plane. So in the control plane, we will configure the MAC VRF configuration. Now, what is MAC VRF? Just like IPVRF, which is used to provide layer 3 VPN service, MAC VRF provides layer 2 VPN service. Same thing, RDRT. So RD is to uniquely identify a route, and RT is to import the route in the right routing table. So now in step B, what we will do is once the control plane is set in step B, we will define the VLAN to VNI mapping, and then we will assign the VLAN on the port here. Once you do it, now if you want to add one more layer 2 service or for an other VLAN or an other subnet, you just have to repeat this step. Step 1 and step 2 are already done. So you build the services over your underlay and overlay. All you have to do is just repeat this. So now let's jump onto the CLI. We will configure each step and then we will verify our configuration. Step 1, we will configure the underlay, which is simply the OSPF, and you can see we will configure the loopback IP on CLEAF1 is 01, on BLEAF1 is 02, and our spine is 03. Okay, and we will enable the OSPF on the loopbacks and also on the ports. Done. BLEAF and spine. So our step 1 is done. So you can see that OSPF is now in the full state, show IP route, and I can see the loopback IP of CLEAF1 and the BLEAF1. So it means our step 1 is successful. Now let's move on to step 2, which is that we will build our overlay, okay, the control plane and the data plane. So let's go here, and here you can see that we will configure the BGP. We will define the router ID, no BGP default IPv4 unicast, because we don't want IPv4 pairing with the spine. So we only want BGP EVPN. So remote AS and update source is loopback 0 and send mm, community. Okay, and here you can see on the spine we will we will define CLEAF1 and BLEAF1 as a route reflector client. Okay, so let me copy this config and paste into BLEAF1, and so this is our control plane config. So done. Now let's configure the data plane config. Now you can see here that I am using the same loopback which I used for the eBGP pairing. Now in this scenario we can do that because there is no MLAG. But suppose if you have MLAG, you cannot do this. Why? Because MLAG uses a shared IP address, a shared loopback IP address uh, between the MLAG peers for for the VXLAN encapsulation. Okay, so in that case, you have to configure one more loopback IP, loopback one, and you will use that as your update source for the VXLAN interface. And for the EVPN, of course, you will be using individual IPs, loopback zeros. But here it's fine. So now let's configure our data plane. Done. Okay, now let's see, show BGP summary. So let's go to spine and do show BGP summary, and you can see our L2 VPN is established. So now let's verify the data plane. So show interface VXLAN 1. So you can see here that the source port is set to loopback 0, but you can see down because we have no VLAN to VNI mapping. So now check show VXLAN flood VTAP, and you can see there is no information because there is no layer 2 VPN configured yet. Now let's move on to our next step. Now we can configure our layer 2 VPN. So here what we are doing is, under the BGP we define the VLAN, we define the RT, and redistribute learn. Uh, it's same as we do redistribute connected. So, and then this is our control plane configuration for layer 2 VPN, and this is our data plane configuration where we map the VLAN 10 to VNI 10,000, and then we assign the VLAN to port. So let me do this. So CLIF 1, BLIF 1, and now we will configure server 1 with the VLAN, and we will pass the VLAN on the port, and similarly server 2. Okay, okay. Up till now, we have built the underlay, we have built the overlay, and we also have built the layer 2 VPN. So, but we have not yet initiated any ping from our servers. So let's see how the control plane and the data plane on the leaf switches look like. So now we will check what happens. Show BGP EVPN instance VLAN 10. Let me put it like this. So here, what we can do is we can do show BGP EVPN instance VLAN 10. You can see, you can verify your configuration, route distinguisher, route target, okay, and the local VXLAN IP address. Okay, now we can do show BGP EVPN. Now you see here, this is the route type 3. So here you can see that now as we have configured the VNI and the control plane, so the switch is advertising the presence of the VNI on this switch, and this advertisement is coming from the B leaf switch. Okay, so we can see what this switch is advertising to. Spine switch. So show BGP neighbors 172.16.0.3 EVPN advertise routes. So here this switch is advertising this to spine. Okay, now we can see what's happening in the data plane. Show interface VXLAN 1. You can see now the VXLAN interface is up and I can see the mapping here. You see this mapping, and show VXLAN flood VTAP. This is the result of what? That route type IMET, which it received from the belief 1. So the switch sent the advertisement that okay, if there is bump traffic in this VNI, okay, VNI 10,000, send me that packet, send me that traffic, okay. And let's see, is there any MAC address? There is no MAC address because we have not initi initiated anything between the servers yet. So show VXLAN address table. Is there any MAC? No, there is no MAC. So now let's see. So now between the switches, only this route has been advertised and received. So it is sent to all remote VTEPs as soon as a VNI is provisioned. Okay, so CLEAF1 will send this to spine, and similarly the BLEAF1 will send this advertisement to spine. So as soon as a VNI is provisioned, and this is used to signal interest in receiving the bump traffic. Okay, and what does it contain? Its type, RD value, RT value, L2 VNI. Guys, please pay attention. This is also sending the L2 VNI and also the VTAP IP. These two things are very important. Okay, this is the configuration which we did where at the data plane level here and here. You see, so it will advertise this two information, and then it will uh, also mention that tunnel type, and the next hop is loopback 0. So now let's ping now and see if the ping works or not. So let's go to the server 1 and ping 172.16.10.2. So the ping worked. Now check the status of BGP EVPN. Show BGP EVPN. You can see now the MAC. This is the MAC address of host 1 advertised by this switch. The next hop is self, okay, and this is the MAC address advertised the bleaf switch, okay, and you can see the next hop is this. Okay, now if I do show BGP neighbors 172.16.0.3 EVPN advertise routes, you can see that two routes are being advertised, one this and one this. Okay, if you want to look into the details of this route, you can also see the detail. So both the switches are advertising these two pieces of information. This is the route type. Which one? MAC IP, route type 2. Okay, as soon as it learned the MAC from the host, it's started to advertise with the values RD, and this is the IMAT route type 3. Now if we look at the MAC table, show MAC address table, and you can see here the MAC is being learned from the VXLAN interface, and similarly on the bleaf1 show MAC address table. and show VXLAN address table. You can see that how this MAC is being learned from this VTEP. So that's how the BGP EVPN control plane and the VXLAN data plane work. Okay, now what's in the type 2 route advertisement? So as soon as the switch learns the MAC address, it will send the type 2 advertisement to spine. And what's in that? Its type RD, RT, L2 VNI, and the host MAC address. Please notice here. Here we have the MAC address, the host, and then the type, the tunnel type, and the next hop. And when spine receives it, it will send to the bleaf1. And similarly, when the bleaf1 sends to spine, spine sends to the cleaf1. Now, from here, the packet walk, how the ping worked in the data plane, how the R process works, how the encapsulation works. From here on, the process is similar, which I have explained in my previous videos. Okay, I, I have explained this in detail, and it's the same process from onward. So please watch this video. Just go to the VXLAN series, the playlist, and you can find this video. Okay, and you can watch that. So when we hit the ping command, okay, the server will send the broadcast ARP request, and then it comes to the cleaf1, and then the cleaf1 will perform the lookup to for the encapsulation, okay, and the IP header and all that, and it sends to spine, and then the bleaf1 and server1, sorry, server2, and then it will send ARP reply, and then the ICMP ping request, and then reply. So please watch that video. And finally, the VXLAN packet structure. So between server 1 and the cleaf1, that's how it looks like. So when the cleaf1 has to encapsulate it with VXLAN, so it will add some headers into it, the VXLAN header, the UDP header, and the outer IP header. Okay. So that's the end of our discussion. Until the next time, goodbye.